program to check given number is prime number or not. So what are prime numbers? Prime numbers are the one which is divisible by 1 or by itself. If n is the number, then it should be divisible by 1 or by n. That means it shouldn't be divisible by n to n minus 1. This n value shouldn't be divisible by any number between 2 to n minus 1. So what we got to do here is, if I have accepted the value n, you try to divide this n by 2, 3 up to n minus 1. We have to generate a natural number from 2 to n minus 1. So if this n is divisible by any of this number, then it is not a prime number. So first we have to accept the value of n, and 1 is also not a prime number. 1 is not a prime number. So we have to check whether n value is an 1. If it is 1, straight away you can display it's not a prime number. So if it is not 1, then generate a natural number from starting from 2 up to n minus 1. Keep on dividing all those numbers with this n. Anywhere if this n value is divisible by any of these number, then we have to straight away stop dividing and then specify it is not an prime number. So in this example, I'm going to use one more statement, that is an break. So break statement is meant for terminating a loop. Now if you are having a loop, okay, if you have a loop, inside this loop, anywhere if you have used a break, okay, the break statement makes you come out of the loop. That is to terminate the loop. This break we'll be using in this program. So let's see the complete code. In the main program, first is we need to accept the value of n. For that, I'll declare an n variable, and then I have to divide from starting from 2 to n minus 1. To generate that 2 to n minus 1, I'll declare one I variable, and whether the number is divisible or not, for that to identify, we'll take one flag variable. We'll initialize the flag equals to 0. If the number is divisible by any of this number from 2 to n minus 1, we'll make the flag value equals to 1. That means flag, if it is 0, it's a prime number. If it is 1, then it is not a prime number. That's how we are going to take it. So accept the number. We'll give our scanf %d ampersand of n. Let's assume that n value is equals to 5. So first step is you check whether this n value is equals to 1. If it is equals to 1, then that means it's not a prime number. So we can initialize your flag is equals to 1. If it is not 1, then we'll try to divide it from 2 to n minus 1. So for that, you take a for loop, initialize first thing flag value as 0. As we have decided, the flag will be 0 only when it is a prime number. We'll assume that it's a prime number and initialize flag equals to 0, and we have to start dividing it from 2. That means I value should be initialized to 2, and we have to keep on dividing till it is n minus 1. So you can give here I is less than n. So less than n means it will go up to n minus 1, and then here I plus plus. So check here whether this n value is divisible by I or not. That you can do it by giving n mod by I, whether it is equals to 0. If you get the remainder 0, that means that number is divisible. If it is divisible, then we'll make the flag value is equals to 1. Flag is 1, and then we'll terminate this loop. Okay, we'll come out of the for loop by giving an break. Break is meant to terminate the loop, but not this if. Okay, so when I give break, that time it comes out of the for loop. When it comes out, only when the number is divisible. Otherwise, if it is not divisible, then it will not go to this place. So still the flag value will be 0, so it goes back I plus plus with a second next value, that is I3. Again it will come back. So like this it keeps on dividing it. Okay, so let's take here n values as an 5, and flag value has been initialized to 0, and here I is equals to 2. I is starting from 2. So 2 is less than 5 true, so 5 mod by 2 takes here as an 5 mod by 2. Is it equals to 0? No, 5 mod by 2 is equals to 1. That means this condition is false. If it is false, then it will not get into this if statement, go back, I plus plus I will become now 3. Then again 3 is less than 5, the condition is true, comes down 5 mod by 3. So now this time it checks here 5 mod by 3. 5 mod by 3 is nothing but 2. 2 equals to 0, the condition is again false. So that means these statements will not get executed. Then again go back, I plus plus, this time I is going to be here 4. Then 4 is less than 5, true. Then again checks out by 5 mod by 4. So 5 mod by 4 is going to be nothing but 1. So 1 equals to 0, the condition is again false. It will not get to the if loop. Then again go back, this time I value is 5. So we have divided this 5 by 2, 3 and 4. Now at present I value is 5, but 5 is less than 5, the condition is false. It comes out. What's the flag value here? The flag value is 0. That means number is not divisible by any of those numbers. So in such a cases, close this if and then check here what is the flag value. If the flag value is equals to 0, that means it is an prime number. So if flag value is equals to 0, we can display here printf the data given as a prime number. Else if flag has become 1, it will become 1 only if it is divisible. In that case, you can display a printf not a prime number and then stop the main. Return 0 and then close the main function. Now if I had given n value is equals to 9, in that case the first time the flag value has been initialized to 0 here. I value is going to start from 2. I value is going to start from 2. So 2 is less than 9, true. So 9 mod by 2. 9 mod by 2 is 1 equals to 0, false. Then again go back, I value is 3. I will be here 3. Now 3 is less than 9, true. 9 mod by 3 is equals to 0, the condition is true. If it is true, that means 9 is not an prime number. It is divisible by 3. So flag will be changed to 1. So it was earlier 0, now it is going to be 1. And then break. When I say break, it comes out of this for statement. It comes out of the for statement here. So it comes out of the for statement because when 9 is divisible by 3, you need not again go and compare whether it is divisible by 4, 5, 6. If the number is divisible by any of the number, then immediately you can make flag value as 1 and then come out of the loop. And after coming out of this else part, you check here what is the flag value. Flag value this time it is equals to 1. That means it comes to the else part and display here not a prime number. And then stops the program. But if I had given n value is equals to 1, then it will not do all this stuff. So in the beginning itself we are checking here whether n value is equals to 1. If it is 1, immediately we'll make the flag value equals to 1. Then it doesn't go to the else part, comes and checks here flag equals to 0, false. Then it comes down and display not a prime number. So let's see the output in the code block. Fine, here we have accepted the number to be checked as a prime number or not. If n value is equals to 1, flag equals to 1. Else we are starting from 2 up to less than n. And anywhere it is divisible, flag will be made as an 1 and then break. When you come out, if flag is 0, given number is a prime number. Else, if it is 1, then given number is not a prime number. Let's build this block, run it. So it's asking for the value. We'll give the value as in 5. So it will display here given number 5 is a prime number. So I'll run this and I'll give this time the value as in 14. So it will display given number 14 is not a prime number. If I had given here 15, also it will display 15 is not a prime number because it is divisible by 3. So here if I give 13, it will display given number 13 is a prime number. This is the program to check whether the given number is prime number or